record a class. We already talked about collections quite a lot, and we made lists, for example, queues, stacks, etc. So we did, but streams is a little bit different. And today we will just try to touch this, because it's hard to understand when you speak theoretically what are streams and what are collections. And we will try to touch some kind of very basic examples. We'll try to write a code without streams, with streams, so that you understand the difference. And I hope we will make it simple to understand, and you will try to get to this basic knowledge. So for this one, we need to open our favorite IntelliJ IDEA. Here I have the previous vectors, yes, so here, but I will create a new window. I will create a new project which is totally empty. You can also try to, I will call it streams, and you don't need to add some sample codes. It will be like that. And it doesn't matter which Java you take here, because actually streams started to be in Java 8 and more. After the Java 8 they appeared, and before that streams were not possible to do. And now here, let's go forward. And as you know, IntelliJ IDEA is a very good tool for Java programming, because when you write classes in Java, yeah, come on, join. When you write some code in Java, sometimes you need to import the libraries, the classes, and if you don't like to write it by hand, IntelliJ IDEA makes it very simple. So here in the folder src, yeah, you can feel free to close the windows or so. And let us make a main class. Let us make a main class, and we can call it main. And now here I will create the main method. Okay, and yeah, you can write like this with 3 dots as well. Sometimes I write these brackets, sometimes you can write 3 dots, it doesn't matter. So here let us try firstly to make some system out. So system out println, and it will be hello streams, yes, streams and collections. So this will be the topic of our lecture today, and let us try if we can launch. We always check it like this with students, because sometimes if you don't have it, you see everything works, so we can make sure that everything works. And now let us try to make very simple things. Let us create a list of something. Yeah, so a list, we can create a list of something. Just do you know what is a list? It is a special data structure where you can put one amount, another. So let us create a new list of strings. So you know, just you can do like this list, and it goes from Java utils, so you can define it like that. So here it goes, and we can define string type, because we are going to have a list of string values at the moment, yeah. And let us try to create, for example, numbers or list. Let us make some list is equal new list, and we can do like that. So, but we don't need to, we don't need to do such thing. I don't want to make it like that, so I will make it close. Here I want to create a new list of string values like that, and here implement methods. No, I don't want to do that. So here, of course, we will make it a new array list. We'll make a new array list, then we will not have to implement this, because if we take the list, then we have to implement all these methods there. So we will take like that. So here now we have the array list. It is a special data structure which is called, it is a part of collections, yeah, and you can put something there. But now let us try to print the list, and we will see that it is empty. System out println, and we can write list here, so we can just print it, and we will see that we will have an empty list. Very simple. But yeah, you see, so we have an empty list. Now, do you know how to make it a little bit filled with something? What do we need to do? And if you have just a kind of collection, if you have list, data structure list, what you can do is this: you can use that list and you can add some methods to that. Do you know how to add some methods? To add some information to the list. Do you remember maybe, or maybe do you have any idea how I can add, for example, some text to the list? I can do the following. I can write list as I defined the list here. You see, I defined my list, and then I put a dot. And you see, when you put a dot, you can easily, with IntelliJ IDEA, you can easily see what kind of things you have there. And you have a lot of different methods, especially the bold ones, which you see them in front. You can add a list, something, you can add some string, some index, you can add all, you can add another collection there to the list. You know, you can add to the list one more collection. You can get something from there. You can add all, okay, at first, at last, clear the list and contains the list, so you can get some if the list contains something or not, and it contains all and equals, so get first, get last, hash code of the list, index of the list is empty. So you have a lot of different methods here. Yeah, so you just press a dot, and IntelliJ IDEA gives you a hint what you can use. So we need to add some information to the list. We need to add some objects, so we just use add. And as we have defined the list, which is string value, so here we have to define some string. I can define 1. So if I define 1, you see here I have the system out. Then I can just send it to this, and let us see what will be there. You see, I have 1 here. You see it well? Yeah? Yeah, okay. So you see the code is very simple. So it's like the data structure you have created, the data structure list, and here you can add. Do you have any questions about this? Do you understand what is there? Everything is understandable. Or maybe you just have some questions about it. For example, why we write it like this? This is the syntaxes. Yeah, it is like the list we define, and you can see as soon as you write a list, it appears also here. And when you delete this, for example, it means that your list becomes red. Why? Because you need to import it from Java. Initially, Java doesn't have it, but as soon as you use it, it imports. Why it's needed? Because Java wants to save some memory. When you write a code, you don't need the list as soon as you don't define. And as soon as you define it, you need it. So that's why it means that you have to download it to your project, and it will be there. Sorry, someone wants to join. I will now. Okay. Now, welcome. So, as you understand, we have now defined, so we don't have a list, so we can import the class like this. The class is important and everything is fine. But the class is already predefined, so you just write import. It means that your project will be a little bit larger in size, but it will use the opportunities of the list. Yeah, so this is important. Java is made of different classes and all the time. And here you can see you define array list, so you can also use the array list because you cannot define list by itself. Okay, so let us add a little bit more numbers, like something you can do like this. For example, 1, here you can add 2, and if you do like that, you can start, then you will have 2 elements already in the list. You can see 1 and 2. The list is being printed by this line. And we can do more elements. We can say 3 and 4, yes, and so on. And we are going to create a list like that. So this will be a kind of a collection. So 5 and 6, and then we can add some 4 more. And here you have 7, here you have 8, here you have 9, and here you have 10. So this is how you do the collection. So you create a kind of array. Yeah, sometimes we call it array. Sometimes so collections is very abstract thing, but you can have different variations of collections. Yeah, and at the moment we have just a list, and if we launch it, then you will have our list printed. It's very easy to print a list, and you can see that all elements are here. 5. I will make it with large letter. Okay, so this is like this, and now let us introduce what is a stream, because we have you have to understand what is just a collection and what is a stream. And if you speak about a stream, it is also like very abstract meaning, and if you speak about real definition of what is a stream, there is no such distinct definition of a stream that is this, but this is a kind of the way how you can handle the data in Java. And the thing is that sorry, I will accept someone. They are accepted already. So the thing is like that, nowadays we have very large powers of computers. We handle a lot of data, and this data should be processed fastly. For example, if you get them from the database, send them to the database, you handle them somewhere in the code, and so on, and how you save them, and sometimes the data is synchronously changing and all the time, and then you can put them in the stream, and this is one of the possibilities. And it is also important to understand that stream has internal possibilities to make parallel work. So sometimes you can launch the code not on one computer, not on one core, but on parallel cores. And streams have special built-in methods, and you just set them. You want to do it parallelly, and it does it parallelly as long as it's possible. So it is much better for the programmer, for the software developer, to use the streams sometimes, not always, yeah, but sometimes it's better not to use them, for example. But if you know how to do that, it's very nice, because it helps you to make the code less. You will see today. We will see different examples. I will make you an example without streams, and then we will make it with streams, and we will see that the code does one and the same thing, but it is a little bit different. So now I'm just using very primitive example. I have a list, and I have created just a list by myself, like doing like that, but you can have different versions how to create a list. You can just define an array. You can just write this is array, and this is all. You can also define it, but now I have used this structure, so it doesn't matter. And now let us make stream out of the list, because now list is just collection of data, and I want to make stream of it. Yeah. So what I do, I just define stream. It is another class. You see it's red now because I need to import it, because it's not imported here. And as soon as I write the stream, I can define stream. As you know, in Java, when you write with large letter, you define a class. If you write a small letter, you can define a variable. Variables in Java are always started with small letters, and you cannot start Java variable with the large letter, with the capital one. And is equal, and then we can create how can we create it from our stream? We can use our object list and make it stream. So and did you see that it was a parallel stream as well there? So I will import the class. You see the class is imported. So it means that Java, when you compile the Java jar file, it will be a little bit larger in size, because you also use streams. And you see, if I delete this, and if I put the person, you can see we have stream and we have a parallel stream. And if you use a parallel stream, it's okay, you can do that, but it will run parallelly, yeah, on the possible PCs, then on the possible cores. And now let us print the stream. So we can print the stream, and we can print system out, println, and we can write stream. So let us try to print the stream. What we do, let us launch it, and we will see some kind of special symbols, which is not understandable for us, yeah. But it doesn't mean that you don't have a stream. Sometimes we speak with this as the array. When you were maybe in the previous lectures, we defined some arrays, and when we define an array, we also cannot print just an array. We can print it as a, it will be also given something like that. But here, this is like what stream looks like. It's something like that, and here it is add some address, so you have the address to the stream. Is it understandable? More or less, yeah? Okay. And now let us try to see what we can do in order to print to the stream. So we can do like this: stream for each, and we can write like system out println. Okay, let us try to see what we have. You see, we have everything done. Yeah, but it is on each line. Why? Because I used here println. If I define it like this, then you can print it in one line. But there will be also some nuance. You can see what is written here. When I print it in stream, it prints it like 7, 6, 9, 8, 10, 3, etc. So it doesn't give me the sorted string. You can see that, yeah. So it's like it makes it like that. Okay, not a problem. But what I want to say that the data in the stream are handled a little bit differently, yeah. And here I'm using for each. Then I can do it a little bit more simple. I can write it like this: stream. Then I can make map, and here I can make, for example, E and E plus something like that. What do I do? Look, what is the result? You see, I have it now 7, 6. I have made it the space between. And now, during these lectures, we will try to work with streams. We will try to understand basic things that we can do with streams. Because for you now, it is something like, what is that? If you haven't worked with streams, why I'm writing like this? What is this? So you need to get used to the syntax. Because have you used streams before? No. And your friend, have you used streams? Yeah, and you guys online, have you ever used streams before? Anas? Aves?
No, sorry.
No,
I
you
haven't
haven't.
used
You
it.
haven't, yeah? Okay, so this is
Yeah.
totally new for you, yeah? So then we have to try to understand a little bit like what we do for with the streams, yes? So that's why we are here, and I'm trying to give you some basic knowledge for that. So let us try to analyze and to try to find out how these streams work and what is so special around them, yeah? So first of all, okay, so here I leave the code. I will leave everything here because later I will save the code and I will upload to Moodle so that you can take this code, run it, and test it, maybe comment something and understand more. So most of all now, let us try to create another task. So here I will just, I showed you a little bit of the streams and what is the difference between that. Yes, oh, hello guys. And now we are going to implement a little bit different task. So let us try to make a comment here so that we know that here we start something new in the code. And let us define an integer array. So if you want to define an integer array and it is equal, like I want to define some kind of array, for example, like that, and I can define an array of numbers. I will define an array of numbers, for example, 50, 60, 70, 80, 90, 100, 110, 120. So I have defined an array here with numbers. Now we need to figure out what we can do with this array, because we need to give some task to the programmer that the programmer will do that, And then we will try to see how how this can be implemented with printing the array, for example, in normal way, and printing the array using Java streams. So now we have a task. We need to print all the numbers before 90. So how to do that? Do you know how to do this in Java? So you need to you have an array, you have the array, and you need to print the numbers from the array which are less than 90. Less or equal, let's say so. For example, so the result will be 50, 60, 70, 80, and 90. But now maybe before we do this, let us print all the elements of the array. All the elements of the array, printing them like in one line. So 50, 60, etc. So what code shall I write now? Do you remember cycles, loops? Yeah, loops you remember. So we need to make a kind of a loop. And what I want to say, so here I can make like four. When I have array, I have a special kind of structure. You have sometimes you can define, for example, you can define int. We usually wrote this text. You can see int I equals, for example, 0. Then I less than r dot length, and I plus plus, and then here we can write system out println, and how do we write? So we can write r I. So if we write like this, what do we see? We will see all the elements basically written one by one. Yes, so here we have 60, 70. So we have starting from 50, but 50 is here. Why is 50 here? Because here in the last row we make print, and this print is not putting this enter, so it is just staying there. So in order to avoid it, I would like to just print a system out println. I will just print an empty line. It will make it possible to go to the next line. This is why I'm putting this piece of code. And then we can see that now if we launch it there, you can see 50, 60, 70. Basically, we are printing all the numbers which we have in the array. Yeah. Let us try to add some more. Then it will be also printed, because we are doing the cycle until the end of the array. But we can also rewrite the code. I can write this code like this, but I can define another way. I can write another way. I will show you how to print the content of the array without those i's, etc. I can do it quite easily. So here you can write 4. You can write 4, and and also like this. And inside, what I can do, I can create int. Int means like iteration. Int, for example, I, and then I put colon, and I put the array number. So what does it mean? It means that I will print all the elements step by step. I will take all the elements there which are in the array. Do you understand? And now what I will do, I can write system out println, and here I will just put I. Look what will be the result. So I will maybe I will write here system out println and here I'll just write something like that to see the separation. Yeah, and now let me check what is there. You can see that the result is totally the same. So this one and this one make the same, but tell me please, which structure do you like more? This one or this one? This one, yeah? Because it's more accurate. And this is nice to see a little bit of nice code, yes? So this is how we write. But you understand both of them, yes? And online, guys, I hope you also understand that this is actually the matter of how we write it. In Java, you see you're very flexible for that. Now, if we do something with the streams, let us try to do that with the streams. And now we can write it with the streams. Let us try to make here system out println, and then we can do again maybe we can do something not like this one, but we can make such classes so we can separate just the printing. And now let us try to figure out how to make it a stream. So first of all, we need to make it a stream, because here you can see I have made it like a parallel stream or stream, it doesn't matter. And here I have it like this. Let us try to make it from array as well. Let us try if we can do it. Okay. So we can create, for example, here a stream. You can see, and like that. So we can create. Now we have defined a stream. So basically, we can try to make stream. And now what we do, you can see it is like we have to create it like that. So here we can write is equal, and we can write r, and we can write like stream like that. We don't do that, yeah, so here, but we can write like arrays stream, and here we have r. So what we do, we have created a stream. Now we have created a stream, but now we would like to have what? We would like to do something else. We would like to print all the stream. Then we can write for each and this guide. So we can write like that. And of course we need to put the place. And you see it goes normally. Now let us try to print it. And you see what we have? We have very nice kind of things like that. As you know, the streams are putting all together. Because the data I put, as you see here, you have total different syntaxes. But if I write it println, then let us see how we can do that. And you see the result is totally the same again. So I show you now 3 different versions how you can print the whole list. Do you understand it, guys? Yeah. This is like, you see, I'm talking, and then it just, when you are online, it means like you have a lot of delay because of the connection. Somewhere the server could be somewhere in India or Pakistan, and then I go back, and so it depends, or it could be in the US or in Europe, yes, so where the server is, and then you can send it back. So guys, which version of the code you like more? You have now 3 versions: the version number 1, the version number 2, and the version number 3. You see that here I used like 3 lines of code. Here I also use 3 lines of code, but less code, yes, and less written here. But when I'm using stream, it goes much more easy. Yeah. So now let's imagine the following: that you are going to make a little bit of substitution of your current version values of the array. You have the array like 50, 60, 70, 80, 90, 100, 110, 120, and you need to add 10 to each of them. Imagine that you have some kind of, I don't know, these are, what could be this? This could be some bonus points, for example, for something, and then you earned 10 points for each of the position, and you need to modify your bonus points. So now you have to have here 60. Here you have, or maybe you can have here not 60 but 53. We are adding some 3, for example, here. Here will be 53. Here will be 63. Here will be 73. Here will be 83, 93, etc. So now we have to take this piece of code, and we need to modify this piece of code so that now you are going to have those guys modified. What you are going to do here? Now, how you are going to change it? What you need to do? Because you see the array is here, but I would like you to change this array so that you have here the elements like 53, 63, 73. So you need to add 3 to each of the element of the array. How you can modify the code? So you need to change. You need to write some code here for this method. How you are going to do that?
We will add plus 3.
Yes, it is very simple. You can write like this: r index I, yes, is equal, or if you know this structure, it is even better. I can use like this, and here you have 3. So if you understand this structure, this is very nice. If you don't understand, this is like r I is equal r I plus 3. This is, I am putting this in the command, so to understand that you can use this way or you can use this way. And now if you launch that, you will see that now you have it like this all the time, you can see. But now it modified everything. I want to start all the time from scratch. That's why here I will create one more array, but I will create array 2. This will be array 1, so that we all the time work with different arrays. I will do like this because then we will not modify it. Yeah. So here you can make array 1, array 1, array 1, array 1. Here I will create array 2. So now here I have to create array 2, and you see this code is much more easier. And here I will do the same with streams, but I'm going to make it array 3, and here I will put array 3. Yeah. Now let us try to do the same task with these guys. So what shall I do now in this cycle? So how can I modify that code to make different bases of the array? Because if I now run it, you can see that let me run it. You can see that here is happening the following. Here you can see the array is modified, but for the second option you still have the same, so you need to do the same. It needs to be modified. You need to make it so what can I do here in order to modify? Do you have any idea? What shall I write? Because this is a new structure for you. You see, here it was easy. You have index, you are iterating, and you are addressing the element of the array. But what you do here, you have I, and here is semicolon and array. What does it mean? That it means that I itself is already this certain element of the array. So you basically don't need to modify it like this, but you need to write it like I. But maybe I can write here x in order not to mix you. I can write here x. It doesn't matter what I write here. Yeah. The only thing, I define some kind of element because it's integer. That's why I'm writing here integer. But it means that it takes into x variable you will receive each element of the array. And now what shall I write here? What piece of code? It will be x plus equal 3. Yeah. Do you understand this piece of code? And now you can see, we can go for the thing, and we can see that the second is also modified. So we have done the task using this method because it does. And now the last method, what shall I write here in order to make the same? Because now here I'm using totally different structure and I'm using streams. So how do I put it into here in order to modify it? So here I need to make mapping. Do you know what is mapping in programming?
It's like building function.
Building, yeah, it's like mapping is very often used, for example, in signal processing, in some kind of things. Then we have one value, and you want to make like a shift or something to all the values in the array, then you can use mapping. Very often it is like logarithmic mapping. Sometimes it is in the Internet of Things it is used, and it is used very often in such things like you are collecting data from some sensors. And these sensors, they have data, raw data. It is just, for example, voltage. If you are parking your car, for instance, you have the sensor which makes the ultrasonic sound going to the obstacle and going back. Then it just sends the sound, receives the sound, and oh, thank you very much. Yeah, it sends the sound, receives the sound, and then it means that it calculates you see the distance on your thing, for example. You see some visual approximation how the object is close to your car, but originally in the sensor it's just the voltage. It means like you have one voltage, and when you have when you are closer to the object, the amount of voltage changes. And we need to understand how to make voltage, the change of voltage, into the meters, for example. Then we need to use some mapping. So we need to take the voltage, maybe apply some mathematical functions, logarithmize, make it into power. There are some kind of special mathematical function. And then it means that you're just modifying. And here we do the same way. We are going to modify each element of the stream and change it to some different place. So what we do, we just need to add map. We add map, and we need map, and now we need to enter what we put into the map, because we need to give the law how we modify them. So what we are going to do, we have to figure out, we take each element of the stream and we have to define it as a variable. I can write, for example, variable. It doesn't matter. So I will take variable, make it like that. Yeah, so it means like the arrow, yeah. And now my variable becomes the variable plus 3. So just make a law, and that's all. So if you start, you have done the mapping. Yeah, and you see it works. Got it? Very good. So this is how we can do with the streams. But you need to train, because it's firstly, if you see it, so how can I do it, or something like that. But if you get used to this, it's very nice. And if you understand that what is a stream, sometimes you can say, you are given a code like a please rewrite it in the form of stream. Yeah, so it can be asked in the job interview. So it could be something like that. So this is what we have, and now let us try to figure some additional things. So now we just making this. Oh, hi. Yeah, Tom. So now we are just making the thing that we have done 3 different options. One option we just use the usual cycle, usual loop, which we already did before. Now here we have a little bit more modified loop, which is nicer. And here we have totally different way of handling data. It is making with streams. Now let us do a little bit other task. So what do we do if we put some, let's say so, restriction that we have to add 3 only for those data which are less or equal than 90. So you see now if we make it, we have it was 50, 60, 70, etc. It adds 3 to all of the data. Yeah. Up to we are speaking about streams, and now I'm showing the difference in between collection and streams and how you can handle data. Yes, so then later you can see I have recorded this class, so you can later see also the thing. But now we are trying. You will get it. So it is a simple code. Now maybe I will finish that, and then I will upload it to you, and you can launch it, and we can try to have some practice with this as well. So now let me finish this one. So we need to make it so that we add 3 to initial values of array only for the values which are 90, 80, 70, 60, or 50. So we don't touch 100, 110, and 120. We don't touch it. How to do it in this syntaxes? So what we have to change? Here we need, most probably we need to put some if, I think, yeah, because if we put some if, then we can do like that. But how we can do that? We can make it the following. We can write here, I don't know if you know such trick in programming, but if you have the loop, then you can go inside the loop, but
you can approach by indexing here,
for example, how?
such as just as you are simply written a array first in, yes, this one.
Mhm.
So in loop we'll just write here 3, so it will approach 50, 60, 70 and 80.
But how does he know in a loop that he has to use 50, 60, 70, and 80, but as soon as he reaches the 100, for example, it doesn't add 3? Because now it adds 3 all the time. But we need to make it so that it adds 3 only for the values which are 90 or less. How can we do that? You think about this, and maybe now I will make a pause. So now you have the project, you can download it, open it as you want, but now please give me some ideas. What shall I do in order to make it possible only for this? You know what we have to do? We need to skip those guys, basically. And how to skip them in the loop? There,
We can just check if the element we're talking about is less than 100.
okay, and what do we do after this check?
If it is, then we print it out. If it's not, then we just skip the loop.
We are not printing it out, but we are modifying, because you see, initial value is 50, 60, 70, etc. But as the result, we have 53, so we just put adding 3. So we just adding the 3 to each element.
If we take for granted that the array is sorted out, then when we reach a number that is 100 or more, we just break out.
Yes, even if it's not sorted, it will be working.
I mean, if it's not sorted, we know that after that number, there could be a number that is below 100, so we just skip this one and continue. But if we know that...
Yes, this is a good word you thought, continue, because you can skip.
Yeah.
And how to skip an iteration in the cycle? Do you know how to skip a loop?
I think break. No.
Break will go out.
Okay.
But then if you put continue, it means that it is no longer executing the other codes of the loop, but it goes to another iteration.
Yes.
So it means that now we put the branch, so we just make if and condition, and then here we write continue. I hope it's understandable for you now. Yeah? So this is like that. And what shall we write here in this regard? We need to compare R1I, yes, to what? It should be larger than 90. Do you understand? Because my condition was I want to add 3 to those guys which are below 100. So it's like 50, 60, 70, 80, and 90. And now look, if you put something like this, when you just launch it, it's gonna work. Yeah, but you see what it does? Yes, it is printing, but it stops printing the same. Anyway, Atom, you understand why it stops printing? Because here you lose the iteration, you don't go there, yeah? Do you understand it? Yeah, this is like that. And what can we do in order to print it? We need to, what do we do afterwards in order to print it? Then what we have to do? We need basically, if we want to see all the content, then we need to start another cycle and print it again. Do you agree? Because otherwise, then we can do, you know what? We can do we can do not only like this, we cannot put like continue, but we can do like that. If you have the condition less or equal, then we can put this one there. This will be more interesting. Then we will save the time. So we can do like that. And then we can launch. You will see that everything will be printed. And we will add only 3 to those guys. You see that? So we managed to do that. But you know that if you have only one line in Java, you don't need to write those figured brackets. And it will be, if branch will be executing only this part. Okay. How do we do in this regard? What kind of line shall we do here? We need to do basically the same, yeah? So this basically is done only if you have if. Understand? So let us try to write it here. So if, here we have also, but here we have x less or equal 90, then you do this, and then it will be executed the same way. And here you also have the same condition. Understandable? Yeah. Let me check if someone maybe online, guys. What are they? They don't tell me anything, so everything is fine. Okay. So now these two guys are done. This one works, but now we came to streams. And what is your idea how you can do it in the streams? Here, this is totally different way of thinking, and you need to apply a filter. Because what you do, you have stream of data, and you are free to filter them. So you can use different kind of data. If you have the whole stream, you can set filter, and you don't need some ifs, etc. So what you do here, you have arrays stream. This is where you start your stream. Here you start your stream. Here you do some mapping on the stream. But before you do some mapping on the stream, you need to do filter on the stream. So what you do, you just add filter. And here you have the predicate. So here you basically define what kind of filter you want to put. And then if you have them something like predicate, you need to do like this. You see here I used variable. It's just up to me. I can use variable, but it's so long to write. I can use just v. And then you see I need to apply the lambda expression. This is a special kind of Java thing. It is lambda expression. Please remember that. So if you talk somewhere in the job interview, so what is lambda expression in Java, then you know what is this. Yeah? And here you have v. It is just denotation of the object which you want to modify or which you want to filter by. So here you just put v. Then you have to add some kind of lambda expression, and then you have to set the condition by which you want to filter. So what is the condition you think about now? And you can try yourself, because it's interesting when you try yourself in this and it works. Sometimes, you know, so here you need to put some kind of condition for the filter. What can we do there? Just think, I will answer.
Again, how do filters work?
How the filters work? It is a special kind of tool for handling data. Okay, I will just make a, okay, I'll start recording. So here we have introduced that. So this is the condition. And now if you launch it, then stream will print only those guys which you have filtered. Understandable, yeah? But now, how can you do that so that you apply the filter, but you modify on the separate things? You can see again with streams, it is not possible to do that now, because if you put some filter on it, the filter will remove. Remember I told you about filter, yes? So if you put some filter, it will take only those guys which you need. But now you can mapping. When you mapping, you see you have one rule for the mapping, but you can make the rule different for the mapping. You can compare variable. If it is less or equal than 90, then you can make it like this, or otherwise you can make it like variable.
So essentially, we're doing the same thing, just in one line.
A little bit
One
like
line.
this, yeah. You mean about the streams, yeah?
Yeah.
Yeah, it's but the syntax is a little bit different, yeah.
Yeah,
And
It's
the,
like
actually also the idea of this is a little bit different, yeah.
there is this like if loop, if else loop. Yes.
Yes, this is if-else loop.
Yes.
So it means that you are mapping a variable. If variable is if this condition holds true, your mapping rule is the following. Otherwise, the mapping rule is the following. This one is also used in JavaScript.
Yes. It's, I think it's will be ternary operators
Hmm?
in JavaScript.
Yes.
We call it ternary operators.
Yes, and this is very nice one, and I use it in JavaScript very often also. So this is how you can handle, and you can see when you get yourself work in different large projects, you will be facing things with streams, and if you don't understand those streams, it will be a little bit harder for you to write the code yourself. So that's why I want to pay your attention. If you want to work with Java, then and also with JS, JavaScript, then you need to understand the streams, because this is important. On a job interview, you can be asked for this, and you can always do like that. So if you have array stream, you can write it like that. Now you can put the following way, and then you can put the following way. So if you don't want to make it large, so sometimes it's nice to have such things, yes? And we can write it in the following way. Java understands it, and it goes like that. Understand, guys? Yeah? So maybe now we have 10 minutes left for the first class, then we will have a break. I can give you a little task, okay? Yeah, please make it so that it prints only first three numbers of the array. If it prints only first three numbers of the array.
Also, we modify
You need to modify them, all the code. You need to modify this code, and this code, so that you receive only first three numbers. Okay? It means that you will receive 53, 63, 73. Yeah. So please program it like that for this, and for stream. Try to do that. So here we can make, if we want to display three elements, we can write like this, and then it's gonna be, here you will see that we have only three elements done. Yeah, three first elements are done. The same you can have here, but here you see you have x, you don't have the counter, then you need to introduce the counter, equals 0, and then you have to do basically like that. If you have like this here, you can add count plus plus. So here count plus plus, and counter, sorry, counter plus plus, and if counter is less than 3, then break. Here you can do like that, and if you launch it, then you can see that here it doesn't work because it already breaks. Here we can have to do larger than 3, because then it breaks if it's larger than 3. But then I think it will display 4. No, all the 3. So this, and this. You see, so it's 1, 2, 3, 4. So they display. Yeah. And with streams, it's not possible to do like that, but you can make it limit and here to 3. So it will be maximum amount, and then it's gonna be the same. You can see in both cases you display 3 elements. Yeah, so this is how it does. I'm sorry, I will get to this on. It's becoming hot in here. So now let us try to give different examples. This is understandable, yeah? Okay, so now let us try to have some other examples, and let us create, for example, some kind of things that we have. Basically, sometimes we need to use these streams, because you know streams is just a tool how you can handle your data structures, and if you know how to use it, you can decide whether you need to use stream or whether you not to use stream, etc. So let us try to go forward, and here we have this our method, so we have practiced a lot already. I will leave it for you, and then I will upload this code so that you can handle it afterwards. But you can try to make some kind of mapping. And do you understand the nature of mapping? What is mapping? Remember I told you here we have mapping. For example, this is mapping. Here we do mapping. Do you understand the nature of mapping? What we do? We take the element of in the stream, and we can modify it. Yeah, and we can set the law how we modify it. And you can see you can get also even the branches. So you can get an if law here. So you have the variable of the element of the stream. Now you get the element of the stream comparison to 90. If it is true, then you get adding 3. If it is false, then you just leave it like it is. Yeah? So this is like the structure. And now, for instance, imagine you have now a little task. You will say me what to do. So let us define a stream. Here we define a stream. Let me define again array. So I am defining the array. Here it will be array 4. It is a new, and here I will make it 1, 2, 3, 4, 5, 6, and 7. So 5, 6, and 7. Okay, now I need to make it using the stream. I need to make it so that it prints out the array which is 10, 20, 30, 40, 50, 60, 70. How do I do it? What shall I write? Just try to make it. So what you need to write, if you want to make the result shall be you have to have 10. You have to have the following result. So 10, 20, 30, 40, 50, 60, 70. So you have this one. Now you have to use streams, and by using streams you need to make the array equal containing these elements. What do you need to make? What command shall you do? You have to. Yeah, but you need to use streams. Yes, if you want to use stream, then you need to write again arrays, streams, and here you have like stream, and here you need to put the array 4. So now you have put the array 4 into stream. Yeah, but what you do with the stream now? Because you have put it into stream now, but now what you do with the stream? So what you need to do? You need to map. You need to make mapping, and here you need to create the mapping rule. So you have the element of the array, but you need to multiply it by 10. So you need to introduce the rule. It will be, you have an element n, and that element n will become n multiplied by 10. Is it understandable? And then you need to print out, so you need to make it print out. Yes, so you need to print it. How do you print it? You can create for each, and you can do the following as well. You can create for each element. If you don't like the structure which I used before, you can write here this one, and here system out println, and here you can have the element the element n. Understandable? You can do like this as well. And let us launch. So you see, this is done, but we can do print, and here this one plus this one, then you will have, wait, and we have, sorry, I put it not here, but I have to put it inside println. Yes, I forgot. Now it's okay, and we don't need this semicolon. So we can try to launch it, and then it's gonna be the following. You can see everything is printed like it is. Yeah, understandable? You have this array, you have this array. So now you have the for each. Do you understand the meaning of map, at least where you can use it? Yes, so you can modify all the structures of the array. If you do like this, here, if you want to modify only odd numbers, then you can create some kind of rule. For example, you can create n 2 equals 0, then this, else n. So what does it mean? It means that if you have, here you should have like this. If you have, you know what is mod 2? It means that it's divided by 2. It has the opportunity if it's even or not even. So if it is even, then you multiply it by 10. If it is not even, it will stay like it is. Let us check. You can see it's even, it was multiplied. Not even, just stayed like it is. Understandable? So this operation is very good when you take the residual. Yes, so like when you divide by 2, you have the residual. You can have either 1 or 0. Yeah. Understandable? Yeah, and then of course you can, after this it's better to have system out println, because then we will go to the next line. Out println, then you go to the next line. Okay, this is done. What we do afterwards, so here we also have to maybe do some kind of other stuff like this, so that you can separate them, otherwise it will be not good to have them differently. So now we can just launch it. You see it's separated, so you can see that this is a different section. And now I want to show you one more thing of mapping, because you can have for example a stream of strings. A stream of strings is very often done because you can do this for surnames, for names, etc. And imagine that you have a database where users enter their names, but sometimes user enters a name and it forgets to make a capital letter for the first letter of his name. Then you can create forced capitalization of that, and let us see how it is done. Imagine that you are reading the stream, so you can create the array of strings. So you can create the array of strings, string array, and R5 is equal, here you can have, for example, John. Also we need to have it in quotation mark, for example, John, David, and I don't know, Anna, and Peter, and Alan. So you see the names are written in with small letters sometimes, yes? So we need to make a little bit different. So let us create a stream. How do we make a stream? Now we have a string of the stream, so we need to have the stream of the string. if we want to make it just a stream, let us try to, we're making it from the array. So if we make the stream from the array, then we make arrays, and then we make the stream, yes? Stream, and then you put R5. So now we have made a stream. Understandable? We have made a stream. But now if we made a stream, what is we made, and that's all. But we need to work with this, so we need to get some values. So now let us print the stream so we can see that, yeah? So we can see that, because you can set equal, you can put the equal, but you can set, you can make it for each, and here you can write n, and here system out println print and here we can put n plus that. So now we will print it. Let us see. See, with streams it's interesting to operate. So, but now let us train a little bit so that you get used to the structure, so to understand. You see, now it makes it like that. But how to make it so that you have them in capital letters?
I think we need to uppercase.
We need to uppercase. You know Java a little bit, eh? Yeah. So we need to make it just uppercase, and then you can have it here. And now we need to use again the mapping operation. So mapping method. So you make map, and here you can create what. So you need to say what you do with the string, yeah. And now here you can do with the string. So you just create the string variable. Then you can have, you see here we have different methods already given here. You can see, you can check, you can make chars, you can make length, you can see like this, and here you see to uppercase. You can see that. Let us make it to uppercase. So now let us try to see what we have. You see? Nice? Yeah, but this is like
all letters.
All letters to uppercase, because you said to uppercase. This will be to uppercase, yeah? Yeah. And you can Google and try to figure out how to make the first letter to uppercase. Yeah, you can try to make. And you can try to see what was there if you make a string, for example, string. Now you can see here we have different finds. Chars. Let us try to see what will happen if you put chars. Something very interesting, yeah. So this is not going to be good, but it goes to print like in a lot of chars things. It makes it a character wise, and you can see, you can try different ones. For example, you can say lines or strip ident, strip here to lowercase, and to char array, to uppercase, to translate, etc. So here you can see there are so many different things, but we can say to uppercase, then it's gonna be all the time to uppercase, yeah. And figure out how to make, just think about this afterwards, how to make only the first letter for that, yes. So this is also interesting. Okay, now what we can do, we can have different kind of thing as well with the stream. If we have this array 4, you see array 4, and now if we print array 4, let us try to see if we have modified it, because you see we have modified it. Let us print so system out println arrays to string, and we can have array 4. So let us print array 4, because you see here we modified the stream, but whether it changes the array, we can try to see. You can see it doesn't change the array at all. When you are working in the stream, here you have divided the stream, you just work with the stream, but it doesn't change the array itself, yeah, because the array itself is here. Understandable? Yeah, because you have the array initial one, but when you put it into stream, you can map it, you can print something, you can do, but it doesn't modify this array. Yeah, understandable? Okay, so now the thing is, if you have a kind of a different data, you can filter. You can see they can filter because we have done this, and now we need to make sometimes a very good option with the stream you have. If you have a lot of different one and the same values you have in the set, and you have to remove it, and you can make it very simple with a stream. Look, if you have, for example, stream, you can write stream off. It is very nice thing. So if you write stream off, then you can write here the values. So you can write the values, for example, 2, 2, 4, 5, 2, 2, 2, 4, 5, etc. So you see, I have given a lot of values, and now I would like to make eventually interesting, for example, count. What do I do with the count? And then we can make for each, and then we can make for example like that if we count, but then we can see now what we have. It will count, but it will not write it, of course. Yeah, you can see, so it counted, but let me make it nicer. So here we have stream of this thing, and if you want for each, you can see here we can have S, and here you can write, if you can put count. No, we can have this then S count S. No, here we cannot put this like that because you cannot make it like that. So here we can write system out println, and here we can put S plus like this. So now we can check. So we have it like this. You can see now we have, no, we will make print, not println. Yeah, here you can see that it prints it, but now if you put such a thing like distinct, oh wait, it removed this for each, then I put here distinct, then look what will happen. You see what it does? It removed all the repetitions. So if you had different repetitions, it just removed it. Understandable? Yeah? So that's good. Okay, and then now you can also write, for example, sorting. Let us make a little bit like this for sorting. So here you can get, let us try to get, for example, this sorted, or this sorted. Let us try to get this sorted. So here if you put arrays stream R5, so it's gonna be, and then we have to make it sorted. So we can create sorted, and you can see Here we can create a comparator. So here we can have comparator, and you can see there are different kind of comparators, and one of them, for example, is natural order. So you can create in the natural order, then you can see how it's gonna be sorted, but you don't see the result because it's not printed. So here we have to create for each printing again. And now we can try. You can see it's made a kind of sorting. You see here we have John, David, Anna, Peter, Ellen, but here we have like this. If you put here Anna with small letter, then it should move to the second position. Yeah, you see Anna has moved to the second position because when you make a natural order, firstly it comes with capital and then it comes with the smaller case. Understandable? So this is like that. Okay. So limit we had, and if you want, for example, with streams, it's very often sometimes you can skip some values. You can have a lot of values and you can skip some. You can get all these values, but you can also skip. For example, here, if you take this one, here we can have system out println, so that we can see the separation. And you see, if you have the same stream, but we need to separate it as well. So if we have the same stream, now you can see that here we have println, and I need to take this one here, and this one here, this one here. So, and now I don't want to make it like distinct. I will remove the distinct, so I can send all of them, but I just don't want to use 4. For example, in this case, you see here is the list of values in the stream, but I want to keep all of them, but 4 I don't want to keep. How do you do it? You can create here skip, and if you put skip, then here you can create, for example, 4, then it's not going to take 4 into account. So it's also good when you just modify the stream. You can see wait, very interesting. It is here you just put 2. No, here you have put 4, but it shows here again 4, but wait, no, I think it is not showing it anymore. So here, this one, it's David. No, let me one more time. So here what we have here comparator, no, comparator done, but here what we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here we have 1, 2, 3, 4. Yeah, it made it, but you see how it made it? It made skip. It made 4 values. It skipped. So these 4 values are not used anymore. Understand? So it means that it takes these values and not uses them anymore. And then you can see you can get some different values that you're gonna have. Okay, Very often streams you can use in order to with you work with two-dimensional arrays. If you work with two-dimensional arrays, then you can have the following. With two-dimensional arrays, let us define a two-dimensional array. I will write integer and here two-dimensional array, so it will be R2D is equal some new array, and here we can have two dimensions of that, yeah. So we can write 1, 2, and here 3, 4. Understandable? So we have like two-dimensional array, and now we can create a kind of a stream for that. So we can write stream, and we can type integer type, and then we can define, for example, my stream is equal, and then you can create arrays. How it was stream, yes, and here you can define your array, so it will be array two-dimensional, but then later you can create what you can do with arrays, yes, and then you can see one of the thing is flat, and flat map to double, you can say. You can have flat map. I think you should have flat map. Let's just try. Yeah, you have flat map, and here you can get what kind of, and you have the arrays, and here what you do with the stream. So then it means that you are going to receive to my stream, you are going to receive this array, and it will be like a stream, it will be like flat map, it will be one-dimensional array. Now look what we'll do, and system out. And we can try to maybe try to print out for each. Maybe we can try to make it like it's one-dimensional array. So let us try. It actually is, if you put sorry. System out println, and here you have stream. You will see probably not very good thing. Yeah, you see you have that one. So it's better if you put for each, and here no, here it's better if you take like S is equal to but you see it will not work because it is going to have here is a little bit different. You already try to have this as integer stream, so you don't need to put this one here, better forget it like this, and here you can put the you can put my stream dot for each, and here let us try to S. So yeah, you see it prints like one dimensional, but you can also print it like that. But you make it like a one-dimensional array. Understandable? Sometimes it's useful. And sometimes you can get very nice thing is sometimes you want to get, how to say, a list from a stream, because you have a stream but you want to get a list from a stream. Do you understand it? So you have a stream but you cannot use it like all, and you can get a list from this. Let me just check where we have a stream. So here we have a stream. We can try to make, for example, the following way. Now let me try to take this part. Again. Okay, so I think that we have to also print system out println. And now we can try to make something to list. So you see here, remember it was, if you want to make system out sorry, println my stream. So my stream will not be printed normally because it is a stream. You see, it's printed like this, but you can create a list from that. So if you want to create the list and you can print it, how can you do that? You need to make the stream out of that. So it's like my stream of, so is equal, here you have, if it is a stream, then we need to figure out how we can write stream of, and here you can get my stream. So this is, you are going to get the stream, but now you will not be able to print it again because it's still a stream. You see, it's still a stream, but now you can apply the things like collect, and you can see that you can apply the collect one, and then here you can create the list. So here you can apply the list, so you can create collectors. You can create collectors, and here you can get to map, and here you can get a mapping function. How you can do it? So you can get, for example, like this. Here what you have there? You have there 1, 2, 3. So this, like you have there 1, 2, 3, 4. And if you do like this to map, so you need to mention how you want to do that. Yeah. So here it is like E to E. So element to element. That, and then you see when it doesn't like it because you need to put some kind of mapping. So here if you want to put like E to E, E to E. So now you can write integer and integer. Let's just try to see now what we have. Still we have it. So it is like, you can put here to list, or maybe to list, not to that one. Let us not make to map because we don't want to make a map. Collectors, to list. Let us make it just to list. And I think I have lost some kind of brackets. This one is here, and we need one more bracket, I think. Yeah. Wait. To list. And you see, now it is list, but it's still printed like that. So here, if you have stream of collectors to list, we need to, it is still like a stream, so you have to, you will not,
I think we can make a list, a new list, and we give this list to the this other list.
how you want to do it.
Like we make a new list, array list. And
Let's make a
we
new
name
list.
it. That's and we put equal and we
You mean this one, yeah? But we need to see it's
array list.
integer, yes? Integer.
Something I remember.
You mean this one, yeah?
Yeah, and we this system also.
We put it like that, yeah?
We give it to it,
Mhm.
and then we print the list. I don't know if it's
You
work.
can try it.
Maybe
No, it will not work. Ah, yes.
there's something else.
No, no. It will not work.
Like I know in Java, I used to do it, things like that. I
Mhm.
think you know it.
You did it, yes? Okay. You were working as a software developer?
No,
Just practice,
learning,
yeah?
yeah,
Just
learning.
practice, okay. Mhm.
But if you don't practice it every day, you forget Java. Java is easy to forget.
Exactly, yeah.
That's what
And here you can try maybe if you have collectors, stream of my stream, then you can get collect. You can try this one, we will delete then. So if you have here if you have it my stream, and here just see for example count, will it work? We can see the count of the element here. One element is there, so I know it's like it connects with the one element there, but what is inside there, you can see we have printed it. It's like here it is array stream, and you can see that this one my stream is connected with 1 2 3 4, but okay, we don't need this. We can just, here we have the stream, but here we have the we have made it an array here, like array stream, but here you can easily do like sometimes with to the listers. So something like that. So let us maybe try to have some kind of tasks. Guys, do you understand? Because you understand it, yeah, but other guys, it's new for you. Do you understand this? So if you put my stream, then it should be 4. Here we have stream has already been operated. Oh, you see, you cannot use it twice, because once you have used it, then you cannot use it, and there is such a thing, and you can. And stream has already been operated upon or closed. You see, and then you have the 2 internal lines, then you don't need it. So here you have the my stream, and then you have operated with the stream, and then you don't need to do that. So Need to be careful with this. Okay, so how much time we have? We have something like, still we have some 40 minutes, yes? Yeah, we have some 40 minutes, okay. Let us try to do some other things. For example, with streams it's easy to generate some many different numbers. Yeah, also there is such example. And let us try to generate some many different numbers. We can create like random, for example, RND is equal, and then you can get, maybe we can do like this, RND is equal to new random, and here we can write, for example, you see ints, we can create that it's integers, and here we can define, for example, 100, and we can try how many integers we want to generate. 100 integers I want to generate. Maybe let's take 10 integers, and you want to generate them from 1 to 6, so it will be from 1 to 5. Yeah, and then what we can do, we can make them boxed, and then we can see, but here you can see that I cannot do that, but I want to make it a stream. So first of all, I want to see that I want to make it streamed, so I need to define it a little bit differently. Maybe I can define a kind of list of integer firstly, and then we can try to get as a list of integers, we can try to create like that. So it's like, let us try to figure out how we can do that. So here I would better prefer if I create one more method, and I can create, you know, private, and we can take the list of integers, and we can create like random RNG generator, and let us return new random, and here we can create this int, like we can try to write, I know, 5, 10, from 1 to 6, but it also doesn't. And then what we can have there, like box, then we can make them collect, and collectors, then we can write to list. So now we can try to have this method, and if we make Okay, we can make it like this. Without this it will not be possible to start. And let us try. You can see we have it. So here it is like you create a random elements, but you put it to the stream, and then you just create it to list. And here you can define different things as well. It is interesting construction that you can do as well with the streams. Is this understandable? Okay, so tired or maybe we can have some tasks, yes?